In this video, we're going to talk about another strategy for evaluating integrals. And this strategy deals with trigonometry, specifically when we have an integral that is sine to some power, say m, multiplied by cosine to a power, say n. So products multiply of powers, m and n, of sine and cosine. So when we have an integrand which is organized in this fashion, then we can use this strategy. And of course, we always have rules, so those powers, m and n, they must be positive, and m and n need to be elements of the set of integers. Okay, so if we've got sine squared times cosine cubed, or cosine to the fourth times sine to the first. And the main thing we'll be looking at will be these powers. So we have three cases. Either m is odd, or n is odd, or they're both even. So let's look at our three cases. So the first thing we have here is case 1. And what case 1 says is that m, the power on sine, if m is odd. All right, so we're going to think about, we're going to write m as 2k plus 1. And we'll use a Pythagorean identity. So we'll use a Pythagorean identity. And that Pythagorean identity would be that sine squared is 1 minus cosine squared of x. Sine squared x is 1 minus cosine squared of x. So what that means is we're going to take the sine powered to the m of x, and we're going to rewrite that as sine of some 2k plus 1 of x. So that's going to allow me to turn this into a sine squared, because using properties of exponents, this is the same as the sine squared of x to the kth power times the sine to the first power of x. So power to a power, you multiply, and when we're multiplying, same basis, we would add. And that's the pattern that we'll always use here. So what we know about sine squared x is that is equal to 1 minus cosine squared x, still to some kth power, times sine of x. So what we've done is we've rearranged this term, sine to the m of x, so that it is some cosine term, and we're going to plug that in up here. We'll still have a sine left over. And what we'll do is we're going to take that sine that's left over, and we're going to combine the sine of x with the dx. So that's going to help with our integral. Okay, and so what we'll do is we will set sine of dx to equal negative d of cosine x. So let's do an example using case 1. Here we have an integral we need to solve. It's a product of sine and cosine, and they're both raised to positive integer powers. You'll notice that the power on sine is odd. So this represents case 1. Case 2, the power on cosine is odd, and in case 3, they would both be even, and we'll do those in following videos. So what I will do here is I will kind of unmultiply this. I want sine squared, and sine cubed is equal to sine squared times 1. So I can say, well, this is the same as sine squared x times sine of x times cosine squared x dx. So looking at this, we want that sine squared in here. and I have just one sine left over. So if this had been to the fifth, we would have sine squared times that singular odd sine. So now I can do a substitution. Sine squared is 1 minus cosine squared x times sine x times cosine squared x dx. And what we said is this sine x is going to come over here and be part of this dx. So sine x dx is going to equal negative d. This guy is going to equal negative d cosine x. So I've got my integral here, 1 minus cosine squared x times cosine squared x, and then I have negative d cosine x. At this point, you'll notice that everything's written in terms of cosine. So we would do a u substitution here. I would say, let u equal cosine x. So doing that gives me the integral of 1 minus u squared times u squared times negative du. Of course, I need to close my parenthesis there. So this is something that's pretty easy for us to integrate. I can multiply this out. I can distribute the negative u squared, and this gives me the integral of negative u squared plus negative and negative is positive u to the fourth du, or rather the integral of u to the fourth minus u squared du, just commutative property. So this is easy for us to integrate. That becomes u to the fifth over 5 minus u cubed over 3 plus c. And of course, u we set to be equal to cosine x. So this is cosine to the fifth x over 5, or 1/5 minus 1/3 cosine cubed x plus c. You can leave that 5 and 3 in the denominator, or you can pull them out in front as a rational coefficient. So that's case 1. And we do something very similar for case 2 when cosine has the odd power. And of course, you don't always have to solve the problems this way. I would recommend using this strategy when you're in this section of your homework, but there are alternate ways to solve these problems. This is just one strategy that we can use. All right, so that's it for this video. I'm going to do case 2 in the video that follows this, and that would be where the power on cosine is odd. In this one, we did product of powers of sines and cosines where the power on sine was odd.